Welcome to this UGC special lecture series. Today we will have a discussion on the subject astronomy and astrophysics, which is being taught in most of the universities in the country and also in different research institutes where the work is going in the field. It is important to know about the basic details of the subject, which is known as astronomy and astrophysics. So first of all, we will like to know that what is basically the astronomy. Both the things, astronomy as well as astrophysics, have a birth from the definition of the cosmology. Cosmology is a science which is used to study the nature, the description, the composition of various cosmos present in our universe. The cosmos can be in the form of our solar system, it can be as a galaxy, it can be as a sun, it can be as a star, or it can be any astronomical object. So in order to know the details of this cosmology, we come across the two basic definitions related with the subject, that is astronomy and astrophysics. Astronomy is the oldest observational science which is used to study the physical nature and the composition of the universe and everything which it contains. As we know, the universe contains galaxies, the universe contains our solar system, the universe contains billions and billions of stars. So therefore, we have a tool based in the science of the cosmology which are used to study the composition and the nature. Then what is astrophysics? Astrophysics is a branch of science that deals the physical laws that govern the structure and behavior of the various astronomical objects. It emphasizes the physical and chemical processes that are going in various astronomical objects, such as birth and evolution of an object, like the birth and the evolution of a galaxy, the birth and the evolution of a star, or the birth and the evolution of a solar system, or in general we can say that the birth and the evolution of the whole universe. So we have a very clear distinguish between the two branches, the astronomy and the astrophysics. We can also add here one more important description, that astronomy we do purely on the basis of observations, and in astrophysics we use various physical laws to construct various theoretical models so that we are able to study the various evolutions, the origin or the other related parameters which can be in general compared with various observational results coming from the field of astronomy. If we go for studying the origin of universe, as we know that from the very earlier times, even different scientists have been coming with different kind of models to study or to give some kind of a description for the origin of our universe. We have a number of models available with us, but everyone is very much aware with a model which is known as Big Bang model, because Big Bang theory is the most accepted model, as it is helpful in explaining and clarifying various things, various results that have been coming from right from the creation up to now for the origin, or we can say that for the evolution of the universe. Now Big Bang model, where from it comes? We know a Big Bang, which is an event basically, has taken place before 10 to 15,000 million years ago with an event where there was a sudden explosion of a system, and with the explosion the universe got slowly created in the form of so many things. Right from the Big Bang, we have been taking very much care about the two very important concepts, that is matter and energy, because this matter and energy which is right now available with us has a birth right from the Big Bang. So when the Big Bang has taken place, the matter and energy, the two related concepts, got created simultaneously. We always say that we have the very big systems in the universe, and these big systems we name them as galaxies. So therefore this matter can exist or have been existing in the form of a number of galaxies. But at the same time, a very important thing which we have already discussed here, that is energy, is very much related with this matter. So the two things, the matter and the radiation, have a very much related origin from the Big Bang. But in addition to that, we have come to know that Big Bang successfully explains two more important concepts, that is the space and time. Therefore we have the very important four concepts, the matter, the energy, the space and the time, which have been created or which have come into action right from the origin of the universe, or we can say that right from the Big Bang of the universe. So the matter, the energy, the space and time have played an important role in the formation of so many astronomical objects which have constituted the main universe. As we know that when we talk about the galaxies, if we look for a particular galaxy, a single galaxy is supposed to be made up of so many things. We have the first part, that is star. We have a number of stars in a galaxy. Then we have the interstellar medium, which is basically the combination of gas and dust, and then we have the magnetic field that is existing there, and then we have the cosmic rays which are present in a galaxy, and then we have some matter which we call as unseen matter. Why I use here a word unseen? Because this is the matter which has been postulated from time to time, but not detected yet from the observational point of view. Therefore these galaxies are the major building blocks of the universe. So if we have or we can say that if we have some very much details, a number of details available for the various galaxies, we can say that we can study the origin of the universe or the evolution of the universe by taking a number of galaxies into consideration. These galaxies, which are grouped in a different ways, we have nowadays in the age of modern technology, we have so many tools available. If we go just before some time, Edwin Hubble, a very famous astronomer, not only an astronomer, he had designed himself from engineering point of view a telescope that is known as Hubble Space Telescope. On the basis of the various observations recorded by Hubble Space Telescope, we have a number of galaxies, existing in different ways, in different forms, and the information have given us the result that the galaxies exist in different types. Like we have a spiral group of galaxies, and we have an elliptical group of galaxies, and one more type, we have an irregular number of galaxies. Spiral galaxies, we know that a galaxy has definitely a spiral type. Our Milky Way, means the observational part of universe, is a spiral galaxy. Then the number of galaxies do exist there in different ways, in different forms. Now the scientists have catalogued these galaxies into different numbers. For example, we will be talking about NGC 41. So NGC means actually the New Galaxy Catalogue. So these galaxies have been catalogued on the basis of their type, on the basis of their shape, and on the basis of their other parameters. Elliptical galaxies do exist in different ways. If we talk about the elliptical galaxies, it is just like the shape of various elliptical galaxies is just like a tuning fork diagram. So starting from the E0 group of galaxies, and then E1 group of galaxies, the E2 group of galaxies, and so on, continuing up to E6 group of galaxies. So means that we have a larger and larger eccentricities available with such kind of formations. Also, as the third group, I have mentioned that we have some irregular group of galaxies. They don't have any regular shape, they don't have any regular pattern. That is why we name them as irregular group of galaxies. Now when we talk about the evolution of a galaxies, because in the field of astronomy and astrophysics, the evolution of a system is very much important. As I have said that the evolution of the universe is itself a very important challenge, and the people have been definitely doing a lot of exercise on this evolution of this universe. So as a single object, means for a single galaxy, when we look for its evolution, we believe on a number of hypotheses which have been predicted from time to time by different scientists, and believing on the one simple hypothesis, that nebular hypothesis. Basically this nebular hypothesis was given by the two scientists named as Laplace and Kant, who say that the system gets evolved on the basis of the result coming from a nebula. Basically a nebula is a cloud of gas and dust. So from this cloud of gas and dust, some kind of system gets evolved which has its own formation, and many things, many objects do exist or get formed from that nebula. So a very simple concept, that nebular hypothesis has been successfully explaining the formation of various astronomical objects. Like we say that everyone in this universe has a birth and then has a death. Similarly, our galaxies have got birth, and with the passage of time, new galaxies go on adding to a general classification of galaxies. So we can say that our galaxies have a birth and remain for a pretty long time, and then ultimately has a death also, but at the same time new kind of galaxies go on adding to the system. When we talk about the observational part of the universe, like the Milky Way Galaxy, as I have already told that the Milky Way Galaxy is a spiral type galaxy, and a very important system which is very important from astronomical point of view, that is the solar system. So where do this solar system exist in our Milky Way Galaxy? Basically, a number of theories have been again put forth there for this solar system. Generally, we believe that the solar system is lying at a distance of 10 to 15 kilo-parsec from the center of the Milky Way Galaxy. I have used it here kilo-parsec, as we know that this parsec is an astronomical unit, because the distances are so and so large that we cannot count them in kilometers or in some other unit. So we use a light year or we use parsec. So that's why we say that the solar system is at a distance of 10 to 15 kilo-parsec. Now, when we look on this solar system, what basically it is, what composition it has, what size it has, what origin it has. So many things again come to our knowledge which help us definitely to know about the various details about the solar system. Again, as far as the origin of the solar system is concerned, we again go to the same hypothesis, that is a nebular hypothesis. Means that the solar system might have got birth from some exploding kind of a star and took the formation of the system which we called as a solar system, with the maximum and maximum mass lying at the center of the system and the number of constituent particles rotating and revolving around this maximum mass. Then we say that this maximum mass, where the maximum weight is, or maximum we have, which is the center of mass basically of the system, is the sun. So the sun along with its other planets constitute the solar system. If we say, what about the size? Basically, the solar system has a size which extended to a number of light years like this. We have a very good classification of the solar system, starting from the sun. Then we have Mercury, the Venus, the Earth, the Mars, the Jupiter. Not only these planets, we have the other objects which are there. The other, we can say that the bodies which are there, like asteroids, the comets. These asteroids, which are the part existing in between the orbits of Mars and Jupiter, and also that these comets, the meteors, the meteorites, which basically come from the interplanetary space and have a travel or has a passage through the atmosphere and sometimes even strikes on the surface of Earth. The comets are there. A comet belt is there. It has been observed that the comets are coming from a distance of about 20,000 light years. So lot of many objects are existing in the solar system. So the two parts are there basically. The two sections are there for a solar system. The first we called as the internal section or the internal structure, and the second one we called as the outer structure. The first four planets, that is Mercury, Venus, Earth and Mars, we call them as terrestrial planets, and the rest of the planets we call them as giant planets. If we compare the various physical properties of various planets, they differ in so many ways. They differ in brightness, they differ in magnetic field, they differ in their orbital period, because if we go to the farthest planet, it is situated at a far off distance from the center of the solar system, means from the sun. And if we talk about the very first planet, that is Mercury, it is very much near to the sun. And we should also know that the first two planets, that is Mercury and Venus, are called as morning and evening stars, because these two planets are usually seen in twilight hours because of the tremendous kind of the light, means heat and other things coming from the sun. So the structure of the solar system is a very simple. The sun, along with its planets, along with the moons, along with the asteroids, along with the comets, and along with the other objects, constitute the structure of the solar system. The properties, as I have already told you, they differ in so many ways. If we talk about the magnetic field of the Jupiter is the largest one, and the Saturn, and then the Uranus, and then the Neptune slowly decays. As we can say that the magnetic field of these various planets, which extended to the so many dimensions up to magnetospheres, can have a very simple kind of structure, generally in the form of the solar wind coming from the sun, the axis of rotation, where we say that the planet rotates about its own axis, and the magnetic field lines. Therefore, we come here to the important central part, that is sun. Everybody knows that sun is an important star. Sun is an important object which has been able, or which is responsible to flourish the life on the planet as Earth. Sun gives us everything. Sun gives us heat, sun gives us light. So without sun, perhaps we cannot say that existence of life is possible. We also say that our sun is a reference star. When we talk about the sun, when we talk about the evolution of the sun, when we talk about the origin of the sun, again we go to the same hypothesis, that the formation of sun within the solar system has been from a nebula, because everything which has come into the real picture has got the birth from the clouds of gas and dust. So as far as the age of the sun is concerned, nowadays we have the number of theories, we have the number of observational results which have helped us in one way or the other way, that the age of the sun is up to now 4.6 billion years, and more age has to come for this sun. If we talk about the age, then we can at the same time say that what the age about the whole solar system. When sun has an age of 4.6 billion years, then the system itself has an age of 4.6 billion years. So sun is basically a star. As far as its evolution is concerned, it has a different evolution. This evolution goes in so many ways. This evolution goes in so many stages. First of all, we will talk about the first evolution. Means that before a star or before a sun has born, so we have a pre-evolution, which we call that as Preman Evolution. Or we can say that an object which has a tendency to grow, an object which has a tendency to get birth. So there is some kind of phenomena which is responsible or which is itself making some kind of mechanism so that the formation of object takes place. We call a star as a protostar. Once the star gets born, we call it as a protostar. Basically our sun, as I have already told you that it is a star, but it is a different star. When we look about the classification of various stars, the stars can be classified on the basis of their luminosity, on the basis of their brightness, on the basis of their increasing and decreasing temperatures, and on the basis of some other related parameters. We have a number of classifications available, and we say that we have particular classification. If we have a particular classification, we call it as a cluster. So we can have here a cluster of star, then the cluster of next star, then the cluster of third star. Basically grouping. We can also say that if we have 100 group of stars, we name it one cluster. If we have a group of more than 200 stars, we name it other cluster. For reference, we can say that we have globular clusters, we have galactic clusters. So number of clusters do exist, and we can also say that these clusters or the group of various clusters basically constitutes our galaxy. So it is just like an hierarchy process. A first star combined with a second star combined with the third star goes on adding to a multiple number of stars and forms a cluster. Similarly, when we talk about the groups, our galaxies exist in the form of clusters, the globular clusters, the galactic clusters, same what I have already talked in terms of the star cluster. Since we are running short of time, therefore the rest part of this lecture will be discussed at the next time. Till then, goodbye.